So welcome virtually to the Acoustics Research Centre at the University of Salford. I'm Trevor Cox and I'm the director of the Acoustics Research Centre. If one of my colleagues could play whack-a-mole with the admitting in the lobby, that would be much appreciated. So what the idea of today's webinar is, I guess one of the things is just to answer some of the questions people have. What is a research degree? How do I apply? What makes a good PhD topic? You know, this kind of thing that people have. So some of it's about just outlining basically what a research degree is and what you need to think about if you want to take it on. I want to give an overview of the Acoustics Research Centre here at Salford, because we're obviously keen for people to come here and do PhDs. We have a lively group of PhDs and we're always keen to have more. And then we'll go into a Q&A with staff. You'll see a few of them on. Some of them are hidden without their cameras on at the moment, who will talk a little bit about some of the areas that they're interested in. They'll do a little talk about that. But we'll also have a chat about some of the issues about applying and stuff like that. If you've got questions, this is meant to be a webinar, so please ask questions. You could just type them in the chat box. At the end, you could raise your hand and you can unmute and we can have a chat, whatever kind of works and whatever works best for you. So feel free to ask questions as you go along if that's useful. So first of all, what is a research degree for those who don't know? And I think it's important you get your head around this because it's quite different. If you say, let's say you've just done a master's or an undergraduate degree, it's quite a different beast. And so you need to understand what it is. And the nearest thing you might have done previously is something like your final year project or MSc project. That's probably the nearest thing you've done to a PhD or a master's by research. So basically taught courses, let's say taught postgraduate courses, that's where you get a broad education. You know, you turn up to lectures, people talk about things, you have seminars, you have exams and assessment. Gives you a nice broad grounding in acoustics for a structured set of modules. Yes, you have a project, but that's only, in our case, a third of the masters. So that's good for getting a broad education in acoustics. Postgraduate research is maybe you've already got a background in acoustics or a closely related field, so you've got that width already, and what you want to do is focus in on some project work, which is necessarily quite narrow in its scope. So you're going to become a real expert in one particular area of acoustics, for example. You're not going to be quite so broad in your learning by doing this. And that's the sort of kind of where the key differences between the two is sort of kind of the breadth of knowledge that you pick up as you do it compared to the depth of the knowledge as you do it. So why do a research degree? Well, one of the reasons is if you're very sort of kind of motivated by sort of kind of for jobs, you actually get paid more. This is the sort of general view, and you can see some statistics there about how it helps with employability. But I would say there's much more to it than just that. I mean, you become an expert in a subject you're passionate about. When you turn up, you do your research, you write a dissertation and have this oral exam called a viva. At that moment, you are really the world expert in that work, and you have this external examiner who comes in, but actually you know more about it than they do. So you become a world expert in some real narrow and important area of acoustics. You get to be at Salford part of a big research group, a world-leading research environment, and I think one of the most important things is fun. It's really interesting, discovering new information, working on stuff that people don't know the answers to and discovering them for the first time. That's a big motivation behind all the staff who are on this call who are active researchers. So there's two kinds of research degrees that we run at Salford, and basically there's an MSc by research. There's some other variants on that, and there's a PhD, but basically the MSc by research, you spend a year intensively working on it. That's a calendar year, whereas a PhD is 3 intensive years of research. They both then have a year's write-up as well, write-up time. So an MSc by research can be done in a calendar year. It sometimes goes a bit longer. PhDs have to be done by 4 years. 3.5 years might be kind of typical. This is research, so you're not turning up, you're not being taught in classes, there's not exams, there's not assignments in that traditional sense. if you come to Salford and there's a skill you need and we have a course on it, you can always sit in on that course, and we have people do that all the time. One of my PhD students, Jo, is on the call here, and she's sitting in on a COMSOL module, a numerical techniques module, to pick up the skills she needs for her PhD from that. So you can sit in on them, but you're not assessed in them. What you have to do in both cases is produce a thesis, 40,000, 100,000 words. They actually vary quite a lot in length. They're sort of typical lengths, but sometimes they're longer, sometimes they're shorter. And they're assessed by an external examiner and also an internal examiner. And then for a PhD, you get a viva as well, which is an oral examination, a couple of hours, maybe longer, of Q&A about the research you've done. So an MSc is a bit like a small PhD, and is some people register for that and then go on to do a PhD. Some people stop at that point. At Salford, there's various study modes. So if you physically come and work with us in our laboratories, then you could study here full-time or part-time. You can also have a split site mode. So I don't know if anyone's coming from abroad and thinking they might stay abroad, but a split site is a mode where you do most of your research abroad with an advisor in a foreign country, and then you come to Salford a few months every year for, say, experimental work. There's also a distance learning mode and online doctorate as well. So there's different ways you can study this. And the times I talked to you about being a year for masters, 3 years for PhD, intensive study plus write up, they're the full time time lengths. If you go to part time, it'll double. What are the costs? These are the current fees for 4,500 or 15,000, depending on which category you fit into. And if you do it part-time, they're just pro rata. If you're a former student, so if you've graduated from us, you are entitled to a discount as well, which is worth having as well. And one of the big issues that we always get asked about is obviously, how are we going to fund this research? Who's going to pay for me to live? Who's going to pay for my tuition fees? So this is always the problem, is trying to actually get funding as well as finding an interesting topic. So if you're a UK citizen, there are graduate loans you can get. There's details there on that website, and there's the 2 values that it can take. So you can take a loan out to do, as you might have done for an undergraduate degree. And then there's various other routes. We can talk about them a bit more in detail, but those, if you look up those links, the top few links, they go through the kind of different ways. But broadly speaking, we have people who are self-funded. They may be taking a loan out. We have people who are being funded by industry. Maybe they work in a company and they come to do a PhD with us part-time, for example. We have people that are funded through various kind of charities and funders of different routes. If you're abroad, sometimes that will be maybe a government even funding you to come and do research. So there's a whole kind of different ways that this research gets funded. We also occasionally have internally funded research PhDs that Salford itself funds in particular areas as well. In terms of how to apply, unlike undergraduate degrees, there's 3 starting points: January, May, and September. You need to allow plenty of time before you apply. The process of application takes some time, so don't think you can start applying in August for September. You need to apply a bit earlier than that, so allow at least 6 weeks in advance. And so what is the actual kind of process is that, first of all, you really need to identify a supervisor in the technical field you're interested in. www.acoustics.salford.ac.uk will take you to the Research Centre website, and you can look at the staff there. Have a look at what we do, look at our Google Scholar paper list, find out the people who are interested, or listen to the talks we're going to have in the Q&A we're going to have in a moment with various members of staff, and then identify who's interested and start talking to them about research topics that interest you. So contact someone. You have to prepare a research proposal. There's guidance there on that link. It's about 1,500, 2,000 words describing the research proposal. Again, we'll talk a bit in a moment about what makes a good research proposal, but we can support and help you with that as well. And then there's actually a formal application process. So before I talk to individual staff, I thought I'd just give you an overview of the Research Centre. I know some of you are students here, so I'm repeating stuff you know, so apologies for that. But for those who don't know, who are external, just to give you a sense, first of all, so We've been doing acoustics research for a long time, since about over 60 years now. We've been running courses since the 1970s in acoustics. Currently, we return 12 research active academics, or faculty, if you prefer to call them that, to the REF, the Research Excellence Framework. We have 10 commercial staff, so we have very strong links with industry, which is one of our key features. 6 postdocs, that's just about to be 7 actually, about 20 research students. So we're quite a large group. In acoustic terms, we're a large group, because acoustics don't tend to have very big groups. And we have research money coming in from research funders like EU, the UKRI, and people like that. And we also have a large amount of income coming from businesses in doing R&D and test income, as you can see there. To support all that work, we have great laboratories, really wide ranging. So that's a picture of an ex-PhD called Charlie Midlads, who now works at NYU in our reverberation chamber. We have a couple of heavy anechoic chambers, ones with hard floors. We have an anechoic chamber with a absorbent floor. Listening rooms, if you want to do listening tests, we've got 2 sets of those. We've got a calibration laboratory. And alongside all that, we have incredibly extensive measurement systems, loads of different systems to do acoustic cameras and Doppler laser vibrometers and more microphones and accelerometers than you can possibly think what to do with kind of systems. So we're really well kitted out for experimental work in acoustics. I'm not going to say too much about our subject areas, which are the next couple of slides, but just to give you a sense of the overview of them, and then I want to go into the individual members of staff. So broadly speaking, we chop our research into sort of 2 areas very crudely. One is about acoustics to do with health, well-being, and accessibility. So I've got 2 big projects on hearing aids, for example, but that could be accessible television. Bill's going to no doubt talk about oral diversity in a moment. It could be about noise and how that harms health and how we might design better soundscapes. And I'm sure I saw Antonio's on the call, we'll talk a bit about that. So mostly, noise and can have detrimental effect on things like accessibility and health. So we do work on that, but also some positive effects of sound. How can we use sound positively? That's one sort of kind of strand. We have a very strong sort of arm into how do people, or even animals for that case, respond, in terms of the bottom case, respond to sound. And then alongside that, we have a lot of work with industrial acoustics, I've called it, but basically this could be architectural, building acoustics, structure-borne sound, vibroacoustics, metamaterials, work on drones, all sorts of kind of different things, computer modeling, measurement systems, signal processing, a lot of machine learning, obviously nowadays. And so we have a sort of lot of stuff working with industry and working on fundamental stuff that is useful for a wide range of different industries. So I hope that gives you a sense of what we are and what kind of research degrees are about. If this is raising questions, please. Yeah, I did say expensive by mistake, Bill. So I just looked at the chat. If you've got questions that are arising, please feel free to sort of kind of put them in the chat box, but otherwise we'll pick them up as you go. And what we're going to do now, having given you an overview, is go to individual staff. I'm going to ask them some questions about a PhD and also ask them to introduce the area. So maybe Bill, first of all, because you're on the next slide, I think staff might be surprised at what order it is because it's random. Maybe you could just talk about what areas interest you for potential PhD applications, and then I'll ask you a question about PhDs.
Okay, thanks. Yeah, so I suppose I'm sort of best known for work for research on soundscape perception. So I probably tend to get more applications for PhD on that sort of topic than anything else. So for those who haven't come across this idea, the idea of soundscape is that it's a way of sort of complicating noise annoyance. Basically, it's a way of saying, well, yes, sound in the outdoor environment, in our everyday environment, both indoor and outdoor, affects people in various ways, and it's not just about noise level. There can be nice sounds as well as bad sounds, and we would like to find sort of more sophisticated multidimensional ways to sort of characterize human response. And that's a sort of huge open-ended question, and there are obviously lots of people around the world working on that, and we've done quite a few bits of work on that at Salford. So there's still lots of room for more research on that. I'm also like pretty interested these days in aspects of difference in people's response to sound. So the sort of the buzzword for that at the moment is oral diversity. The idea that, well, people hear, listen, respond to sound in different ways. So it's not just about normal hearing and impaired hearing. There's a whole sort of spread of diversity out there, which is in some cases somewhat under researched. So there's sort of whole areas of people's listening. For example, how autistic people respond to sound that we don't actually know all that much about. So there's definitely potential for PhDs there. Right, I'll stop going on there.
Yeah, well, I was going to ask you. I plugged your workshop again. I get a prize.
Cheers.
But I know your son is just actually going to start a PhD in Edinburgh, because we were chatting about this. So what did you advise him about what a PhD was all about?
Oh, that's a good
What was the
question.
hidden story from an academic you told him?
What did I say? What did I say to my son Max? Well, he's not doing a PhD in acoustics. He's a sort of AI machine learning person, although his first degree is kind of bioengineering. But one of the things I said to him was, I mean, doing a PhD can be quite a slog. So you have to pick a topic that you are really, really interested in. Like, don't write a PhD proposal in something that you think, oh, this is more likely to get, to attract funding, or to, this is what this big name supervisor is interested in, so I better write something about that, and then he'll accept me. Because if you're going to study something for 3 years, you've on your own a lot of the time. I think you've got to be really obsessed with it. So it's got to be something that really interests you. And the second thing I said actually was check out the supervisor carefully. There are pros and cons to. I mean, you could divide supervisors into two different types. So very roughly, there's the sort of big name who's got like loads of funding, and lots of students, and that can be a big advantage because they've got lots of connections and they can put you in touch with all kinds of people that will maybe help your career. Downside is maybe they don't have that much time for you. The other kind is the a sort of new academic just starting out, which is actually the kind of supervisor my son is going to work with in Edinburgh. And I think one advantage of working with a supervisor who's quite early on in their career is that as a PhD student, your success really matters to that supervisor. If you're somebody's first PhD student, they're probably going to put a lot of time into you, and give you a lot of help because they really need you to succeed. So yeah,
That's it. I think the last
said.
bit of advice is particularly useful, seeing the age we are. So you basically suggested they shouldn't apply to you or me.
Well, I'm just being candid. You asked me what I said. That is literally what I said to him. Yeah.
Yeah, interesting. My son, Edinburgh seems to be the place. My son Michael's doing a PhD in Edinburgh, and he's ended up with someone who's the less senior person, and there is an advantage. You get to meet them often. I would say there's a difference between different subject areas. So one thing you should do as an applicant is read around what is a PhD and what the pros and cons are. And there's plenty of stuff around, plenty of books on it, and some of the sort of horror stories around PhDs happen in certain groups. I think particularly very large groups where you've got people supervising far too many PhD students, so they can't really have the care of it. That's not the case when you come to Salford. We're more like, we're not that many PhD students spread around the number of staff. You can do the sums. It's about 2 per person, 2 to 3 per people. So none of us are so overloaded with PhD students we haven't got time for our PhD students, and you get a very individualized supervision. So I think it's quite different. But yeah, so that's one difference as well. And yeah, my son ended up with the new member of staff. So thank you very much, Bill. That's much appreciated. I might move on to John now. And John, if you want to just start basically by maybe talking a little bit about the areas that interest you and give us a sense of how many more pictures you can get on a slide.
That was my metric. That's how I rate the success of a slide. Yeah, so thanks, Trevor. So here's a collection of things that I'm passionate about, to pick up on your previous discussion. And Trevor also supervised my PhD, what is now terrifyingly close to 20 years ago. I was just looking at the year here, which is kind of scary. So I can testify that he is very diligent and supportive, and I try to be the same. So a lot of my interests stem from that, which was originally from computer simulation algorithms for acoustics, as we've kind of got on the top left. But as time has gone on, that's spread out to cover a whole range of different things, most of which are actually very related, if that's not completely obvious. So, computer simulation algorithms are kind of interested in their own right. That there are people almost in kind of like the maths kind of area that will study algorithms without any really consideration what you might apply them to physically. But that's not where we are at Salford. We're all about actual physical things. We're about human response to sound. We're about designing real products and spaces and things like that. So computer simulation algorithms are, I think, fascinating in their own right, but we're really interested in how you might use them. And that opens up a whole other range of questions, like, can you listen to this? Can you oralize it? Can you hear what's going on? Can we have a human response to the results of these algorithms? Or can we update kind of models of a structural system, like the guy with the motorbikes doing there? That's actually a photograph from a Siemens website, actually, who are really keen on this kind of digital twin sort of stuff. And then also, a computer model's only any use if it actually matches reality. So, you would get interested in things like, can you characterize a sound source, which then gets into kind of loudspeaker measurement and things like that, which I'm really interested in. Can you characterize materials at the bottom center? So that might be microarrays there, or it might be something to do with like laser Doppler vibrometry, kind of measuring the vibration of these things. And also, how do you measure what's coming back from different directions in a room? So microphone arrays also applies to material characterization. Or conversely, how do you create loudspeaker arrays that fire sound off in different directions? And, to the layperson, these might seem like totally different areas, but actually, in my head at least, they're basically all the same, because they're either maths that a computer's doing, or they're maths that you're trying to do with a physical loudspeaker or microphone array. It's actually all the same stuff. They've got some slightly different topics on the top right, coming more from a kind of live sound or electroacoustics, kind of loudspeakers kind of angle, which is, like many people here, has always been an area that's really fascinated me. So I've had some projects on kind of live sound related stuff, compression driven waveguide design, a few things on electroacoustics and drivers and stuff like that. Again, linking into the how do you put these into computer models is another angle. And then finally, the untitled thing in the center with can't count those. Yeah, 6. Thank you for the pointing. 6 large loudspeakers around some sort of box is high intensity acoustic testing, which should probably have a title. Apologies. And that's all about testing the susceptibility of devices and products, often to do with kind of like satellites and space technology, to acoustic noise, because things like rocket launches, for example, the noise is incredibly intense, and bits can break. Things like solar sails and antennae that are quite lightweight are couple very well to the acoustic field and can be damaged. So we have a sort of growing interest in this. I've been advising the new National Satellite Test Facility, people down in Oxfordshire on this, and we're also building our own capability. And relevant to this, we will have a funded PhD studentship coming through, which I don't think has been advertised yet, but will be. So if you're interested in that area and you're interested in actually a funded PhD, which are quite rare, then please do drop me an email and I can tell you more about that.
Thank you, John. Yeah, we tend to advertise PhDs. Obviously, we have social media; they always go on there. But find a PhD or jobs.ac.uk are kind of a couple of sites we use for jobs and stuff like that, where you'll see us when we've got a position that is open. What I want to ask you, John, is you've got quite a large different kind of areas. What sort of skills are you looking for in your applicants then? You know, what might they have studied?
I think it could come from quite a range of areas, really, depending on the which exact angle you want to go. I think most of my things will end up using computer simulation in some capacity, even if you're not somebody who would like to get into the nitty-gritty of programming this kind of stuff. Just like in all areas of engineering, computer simulation is an incredibly powerful tool for prototyping designs virtually and kind of doing experiments virtually. And that's a tool I would always use. So some familiarity with that would be really useful. I teach the module on that here. In fact, actually, that's going to soon be available as a standalone module. So if you come from a different background and you want to learn more about computer simulation of acoustics, we will have a module on that and various other ones that you can actually take standalone in a single trimester, which would help your background with that kind of thing. If you want to get into the programming side of things, then kind of sort of a fairly strong kind of background, kind of mathematics and programming and things like that would also help. I mean, that helps across the board, to be honest with you, but quite how important that is depends a little bit on whether you're more interested in the practical elements or the or the prediction. For the high intensity PhD, for example, I wouldn't let the maths put you off. There'll be a whole range of challenges that I'm sure will be really exciting, but that's probably not the main one in there.
Yeah, I think one of the characteristics of a PhD in acoustics or PhDs in acoustics is they're very broad ranging because acoustics cuts across. So one of the things you might want to think about is how your background best fits into the subject you're interested in. I mean, if we just had, for example, what Bill was talking about, I didn't ask him this particular question, but the backgrounds people come to Bill would be quite different. They might come from a psychology background, they might come from an acoustics background, they might come from a physics background. Because he's interested in human response, there's a whole sort of other area of education that could fit into some of his kind of research that he's doing. So think also about how your background fits best into what you're trying to, what the research topics you want to do. I think it's safe to say if you're interested in sound and you've got a degree, there is probably a topic which will build on your expertise to make a PhD, but there will be topics you won't thrive at. So that's an important thing to read into, and trying to get that sort of kind of right balance in what you want to do. The other thing I think which comes across from just listening to John talk is you might want to think not just about the subject interests you, I'm interested in loudspeakers or whatever, but also what skills you want to use in the project. So if your thought of a good day is to spend it stuck in front of a computer typing computer programming, then that's your idea of fun, and there's plenty of people in this group who like that. Then doing a project, very computer modeling based project with John is a great project. But if that's not your idea of fun, don't choose it. So think about how important are measurements to you, how important are working on computers to you, how important is it working on things like psychoacoustic, human response to sound. Think about what elements of actual doing you like doing could also help shape the project that you're interested in as well. So yeah, think carefully on that as well as on topics. Thanks very much for your time today, John. I know you've got to fly off because you've got exciting marking to do, like we all have. So thanks very much. We'll move on. That's all right. Take care. If you've got questions for John, you can email him or I'll call him back onto the call, but he's just got to go off to do some marking now. I think we're going across to Olga next. So Olga, if you'd like to introduce yourself and just
Yes.
Give us a few minutes about metamaterials and materials.
Hello, my name is Olga U. and my work is in the area of physical acoustics. And I mostly work on developing materials and structures to attenuate or to manipulate sound waves in different ways. Some of the materials I study are traditional ones, and something like acoustic felts, for instance. And in this case, what I want to do is just to be able to predict the properties of these materials. In other words, to predict how useful they can be in making our environments quieter. But mostly I'm interested in unusual materials and structures, a bit more exotic than acoustical felts. And this includes the so-called metamaterials and metasurfaces, which become extremely popular in the last 10 years or so. These structures are artificial, and they're designed from scratch to have some unusual properties. And on these pictures, I think I have acoustic black hole, which is a metamaterial structure designed to absorb any sound wave which is incident on its surface. And also you can see some meta surfaces made of ping pong balls. They're also designed to be perfect absorbers of sound. But other structures I'm interested in have structuring at nanometer scale. For instance, it's on the left, for instance, something like activated carbon felts, and they're also very good for absorbing sound. They're very light and can be very efficient in small layers. But what I'm particularly interested in, what I really love, is to study the properties of these materials at extreme conditions. John already mentioned this. This is when they are designed to attenuate very, very loud sound, which is relevant for applications in aerospace, as John said, and also for military applications. This is the so-called non-linear acoustics and dynamics. That's all about me. Thank you.
Thanks very much. Thanks very much, Olga. So fascinating range of stuff, and materials is just such an important area of research, because if you look at the primary way we deal with noise and vibration, it is usually through some form of material. When people apply for a PhD, Olga, I mean, what are you looking for from for a good person to do a PhD? What do you think the characteristics are of a good PhD student?
I like working with people who love solving different problems, not just to study something, but to be a little bit more adventurous and to apply what they study, maybe even if their knowledge is incomplete, to actually solve something. And of course, also to find an interesting problem to solve. That's what I think is important.
So curiosity really.
Exactly.
I think that's one of the features of a PhD, is that you're searching this narrow topic. I mean, Jo just put she's doing a PhD on hedges. You know, so that's the kind of how narrow a PhD might be, the acoustic properties of hedges. And you've got to really want to pick away in detail at this very narrow problem, and that takes a certain mindset, which is a real privilege to do, actually, because you don't often in your life get the time to devote so much energy to such a narrow endeavor full time.
Exactly.
But it does take a certain mindset. And when you supervise PhDs, how do you do it, Olga? How often do you meet up? What's the sort of kind of process?
We usually meet officially every week, but at the same time, we communicate more often by email, or just have some unplanned meetings on Teams. So I'm always available to answer questions or just to exchange the ideas. So it's very informal, I would say.
Yeah, and I think with the good supervision, it feels, although there's a supervisor-student relationship, it's like teamwork, really. So, and that sort of supervision arrangement is pretty typical across the group. Most will try and do a weekly meeting with their PhDs, excepting sometimes people go on holidays and stuff, so it doesn't always happen. And then nowadays with electronic means in between time as well. So that's very much how most people do it. Thank you very much, Olga, for your time today.
Thanks,
much
Trevor.
appreciated. We're going to move over to Duncan now. Duncan Williams. And maybe you could introduce yourself, Duncan, and chat a bit about the torture you're applying to these people here. No, it's not torture, I know, but it looks like it.
Yes, sure. Hello, hi folks. So as Trevor said, my name's Duncan. I'm a lecturer in the Acoustics Research Centre at Salford, and it does look a bit like torture, these images, but actually I'm one of the good guys, because I'm interested in helping people with sound, not in understanding nasty, noisy sounds. And what you're seeing here is probably what people will find if they Google me. I'm not a rampant self-Googler. Other Duncan Williamses are available, but if you Google my work, you'll find that I'm known for putting sensors on people and trying to understand what's happening in our bodies when we hear and experience sound, and specifically music, because really I'm a failed musician. So I'm interested in how we deal with music as one of those interesting properties of sound. Now, you'll also see, Trevor, perhaps you could help if you could mouse over the talking vole, which is this character here, or in the bottom left, we've got somebody wearing a VR headset and they're experiencing a large scale installation. Both of these are video game type of projects. So I'm also interested in VR and sound for games, as well as sound for music or for monitoring how we work as humans. Rather than sort of talking you through all of these sensors and devices and things, what I'm going to do instead is just tell you what the 4 PhD students that I currently work with are doing. And that might give you an idea about the kind of scope of what you could do. So I won't name them, but one student working part-time is particularly interested in the sound of horror. So horror films and what might make people excited and why they might enjoy the elation of being scared. And if you hate horror films, you might also get the same feeling from going on a roller coaster ride. So how does sound contribute to that feeling? How can it maximize that excitement of being a little bit scared, although you're ultimately kind of, generally quite safe when you're experiencing those things? Another student also working part-time with us is particularly interested in how music can help people if they're not feeling particularly great. So she's got an interest in, she works day to day as an acoustician, but when she's doing her PhD work, she's interested in different songs and curating playlists and creating musical experiences that will help people feel better. 2 more recent students haven't quite pinned down what their PhD is going to be just yet, but one is interested in VR and spatial audio. So how you'd create a sense of space using VR, AR, or the new buzzword would be XR, extended reality kind of technology. And the other is interested in developing technology which helps musicians to create better sounding pieces of music. So actually automated mixing using machine learning, artificial intelligence technology. Sound engineers the world over might weep to think that their jobs are going to be taken by assisted music mixing technology. And I don't think that's the case. It's more the idea that this will be a creative tool that will help people making music at home or with other people. And so these are growing areas, and they're kind of quite exciting topics, because we don't know what will come out of those things yet. But those students have an enormous range of experience and different kinds of skills, which I hope will be more interesting than me just talking about these pictures on the screen from previous years' work.
Thank you very much, Duncan. So these four PhD students at one time wrote you an application which includes a research proposal. So we asked people, and there's guidance online, you can get it. If you can't find it, email me, I'll send it to you, for a research proposal, which I think is about 1,500, 2,000 words now. What do you look for in those research proposals?
Well, I think
in the end, I suppose we should say, in the end, it comes to us as supervisors to evaluate. Sorry, Duncan, I cut across.
No, it is. I think there's 2 things to say. First of all, the research proposal never quite looks like what the more developed PhD students are doing. So it doesn't have to be perfect. And also, you should approach the supervisors that you're interested in working with beforehand as well. So they will help you craft a research proposal that ticks the boxes and makes sense. Personally, what I look for is a sense of enthusiasm, that somebody has gone out there, thought, oh, I've got a great idea. Wouldn't it be fun to spend 3 or 4 years working on this great idea? And the first few months of the PhD are spent really honing the details of the idea, of finding out what's possible, what else has been done. So it doesn't have to be perfect. And what I look for is enthusiasm, a sense of playfulness, a sense of fun, a sense of passion about the subject, rather than my PhD was with a pure mathematician, and I spent years revising and deriving equations. So I kind of want to do the opposite of that with our students. I want them to have fun.
I think the other thing I look for in these is also just a sense that you've read around a bit and you've actually looked into the subject. Now, one of the things that happens when you do a PhD is you start off and you do a literature review, and then you find lots of things you haven't found during the proposal, which means you have to reshape what you're doing. That's fine. But a sense that you have read some of the current papers and understand some of the current sort of issues that are around, so you can frame this in terms of Professor X did this, but I would like to take this idea that they developed, I don't know, in stereo and see if it works in VR or something like that. Something which indicates your interest in the field, I think is important. So evidence that interest, as well as sounding enthusiastic, show you've read some of the latest stuff and at least know what the context is. But don't worry, we're not expecting a complete literature review there, and you will miss things, and that's fine. It's just provided you've done some of it. Would you agree with that, Duncan? A good sort of idea?
Yeah, absolutely. And I think that almost comes by default, because if you're writing in a way that's enthusiastic and curious, you probably will already have been aware of these ideas, and you'll have heard of machine learning and VR and XR if those are the ideas that excite you. So it kind of goes with the territory, that people that are passionate and curious. Yeah, I think curiosity is the real thing that you need to show. And if you're already watching this, you already have that curiosity. So I imagine it will come by default, but absolutely.
Yeah, I mean, it's something which is coming out, curiosity, interested in learning new stuff. I mean, if that doesn't spark an interest in you, think carefully about whether you want to do a PhD, because it's a long time to do if you're not driven by that. Oh, I wonder what happens when you do this, kind of mentality. I think the other sort of characteristics of a PhD that you need to look for are things like you need to be very good at self-study. I mean, we supervise you, but you need to be quite good at not being afraid to sit in a room on your own working on things. There are other PhDs around, and getting that mutual support across PhDs is really important. But you are on your own with this topic, and that's unusual. That's something people struggle with sometimes, isn't it, Duncan?
Yeah, I mean, actually, it was the same even when I did my PhD, which isn't so long ago, 15 years ago ish. You do have to have that self-motivation. There will be long, late, lonely nights where things just don't seem to quite work, or you're doing some code and you can't figure out what's gone wrong. And you need that motivation, and that self-starting part of the process. So it is very different to an undergraduate degree in almost all of those regards. If you're a musician and you're somebody that likes to sit and play your instrument and delve into the depths of it, or perhaps record yourself and re-record it and tweak it until it's just right and it's never quite right, and you spend hours and hours doing that in this kind of hyper-focused state, you would be very well suited to a PhD. All of those, you're essentially training yourself to be a good student in terms of a PhD, I think. So as well as curiosity, we might add tenacity to that list of characteristics.
Okay, well, thank you very much, Duncan. I better move on. So let other come in. Actually, I noticed it's me next, so we'll be very egotistical and do it myself now. So I'm Trevor Cox. So as well as being the director of the research centre, I also supervise PhDs and do a lot of research. Here's a sample of some of the stuff that I'm currently working on. The top left-hand corner, I have two big funded projects on hearing aids, particularly running machine learning challenges to improve hearing aids. So I guess if you look at my research, there's a mixture of things about perception. I mean, if you wanted to know how a hearing aid works and whether it works, that's a perceptual psychoacoustic problem. But also I always had a strand around machine learning and doing signal processing through machine learning and metrology through machine learning. And those two projects, one's called Clarity, you can look that up, it's currently called the Clarity Challenges Project, and the one called Cadenza, which is about music and hasn't started yet. So stuff around accessibility, we'll hear more from Ben on accessibility later on, but that mixture of machine learning and perception is something I do. The bottom left-hand corner is about reproduction. I mean, Duncan's already talked a little bit about spatial audio, but we have had quite a lot of research in different areas of spatial audio. One of my colleagues, Bruno Fazenda, who isn't on the call today, does a lot of work on surround sound, for example. I've put an example here for media device orchestration, a technique that was developed by Salford, BBC, R&D, and Surrey University mostly, in a project called S3A, which is about using ad hoc devices to try and create a surround sound experience. So I'm quite interested not just in the high-end stuff, but how do we get stuff more practical that people will use in their home working? And that's what MDO was kind of about. So audio systems, again, partly about the perception, partly about the signal processing, but also partly about the physics, because my background is in physics, which leads me to the top right hand, which is these are actually pictures from Noe Jimenez's paper, which I did with him. He did most of the work, I should acknowledge that, on metadiffusers. So Olga talked about meta materials in terms of probably an absorber to remove energy. Metadiffusers are about scattering sound in a very shallow depth, and that's some pictures from metadiffusers. My PhD was in diffusers. That's what I started off as. I did a physics degree, then came into acoustics and did a PhD on diffusers. So that sort of works a mixture of computer modeling, measurement, design, and physics, I guess, put all together is what goes into a project about materials and something like a metadiffuser. Where might you use it? You might use it, for example, in architectural acoustics to try and deal with poor quality sound in a studio, for example. And my original area of research, I kind of indicate, was architectural acoustics. It was diffusers. And I chose a picture here of an unusual architectural space, which is actually a bit of my Stonehenge model. So I have a 1:12 scale model of Stonehenge, and I've applied modern architectural acoustics modeling methods to that space. So archaeoacoustics, the sound of the past, is something also that interests me potentially as a PhD. My colleague who's not here, Bruno Fazenda, would also be very interested in doing PhDs or supervising PhDs on what was the sound like in the past. So that gives you, I hope, gives you a sense of sort of kind of the techniques and the areas that kind of interest me. And as I can't ask myself my own question, I'll move on to my next colleague. But first of all, I'm just going to answer. There's a question in the chat, and feel free to add this more questions as they come up. The question is, who retains intellectual property rights when doing a part-time self-funded PhD? And I said it depends on who funds it, because I wasn't read the question well enough. So we do have PhDs that are funded by industry, and therefore the intellectual property remains with the industry, and it's part of the agreement in the funding that the intellectual property stays with the industry. We have PhDs which are funded through public money, and usually at that point there's a sort of agreement drawn up between the university and the student if there's intellectual property to exploit. And I think that would be true on self-funded. The intellectual property you generate while you're at Salford has an initial ownership with Salford, but the university has a sort of rule that students should benefit from this. So there's what we bring in, we bring the tech transfer team in and work out an agreement, and the system they have is pretty fair to the student. So they're looking for the student to benefit from it. But I think officially speaking, the IP initially resides with the university, but there are rules to make sure the university gives out that right across to the students, is what I think the answer to that is. Please correct me, colleague, if I'm wrong. That's when I last looked at the rules. It's probably about 4 years ago. I don't think 4 or 5 years ago. I hope that's answered your question. If it's not clear, please ask me again. Good, thank you. I seem to have done that one okay. So moving on, Ben, who's been very patiently waiting. Hi, Ben. So Ben, Shirley, my colleague, who works on accessibility. But I better not steal your thunder. You better introduce yourself and talk a bit about the research, the great stuff that you do.
So as Trevor says, I'm Ben Shirley. I'm a senior lecturer at the university, and most of my research at the university has been on accessible and personalised audio. Most of that for media, and most of it, but not exclusively, for broadcast media. So this started way back with digital switchover in the UK, this area of work for me, when I was asked to look at how you could make TV sound better for people with hearing impairments. And the more I understood about it, the more questions came about, and we got a bunch of stuff into kind of international broadcast standards about how this could be done. More recently, the sort of next generation audio formats like Dolby Atmos, AC4 and MPEG-H allow for some quite interesting possibilities in terms of personalizing audio for individuals. So, for example, instead of just the producer creating a mix and sending that out to your TV and you get what you're given, there's not a great deal you can do with it. What it allows the broadcaster to do is send many of these elements of the sound scene as individual audio objects, which have metadata associated with them, which describe where they'll come from and what level they'll be at and so on. But it gives the possibility for the user or for the user profile to interact with those audio objects. So a really simple example might be, if you're hard of hearing, you might want more of the speech and less of the other stuff that might mask it. Or if you have a different language that you speak, you might want a different language and so on. But some of the work that we've been doing over the last few years has been taking that a bit further and looking at quite novel ways of personalizing media. So a recent PhD student, and this is kind of typical of the sort of things that I look at, where we look in quite a lot of detail about the perceptual aspects. So what is it that someone that's hard of hearing or blind, partially sighted, someone with dementia we looked at might experience from media, and what would their individual needs be? And then look at what engineering solutions might come from those questions or from those challenges. So a recent PhD student, we looked at that for hard of hearing people, and she actually found that whereas previously all the work had been looking at speech is important, everything else can get in the way of speech, so we get rid of that. Actually, some of the non-speech elements are really critical to understanding the narrative of what's happening in, for example, a TV drama or something like that. So the sound of a gunshot in a thriller or a drama is quite important to understand in terms of what the narrative is. So we started looking at how we could assign different types of narrative importance or different elements of narrative importance to different parts of the sound scene. And a couple of the images you can see on there. So the top right was some work I did I worked quite closely with broadcasters and broadcast technology manufacturers as well, and developers. So the top right there is some work that I did with DTS, which was actually a master's dissertation project. It finished up being where we presented them with 4 different categories of sound which they could mix to their liking, and we learned a lot about what people wanted from that. The middle picture there is some work that we followed up with, which was part of the S3A project that Trevor mentioned a little while ago, where we took it a stage further and we tagged everything with narrative importance at the production end of it, and at the user end we again solved the engineering challenge of, we don't really want to present every user with a mixing desk where they have to mix it themselves. So we had a single dial interface where you could reduce or increase the complexity of the sound scene. And the influence of that interface might depend on what your specific profile was. So if you were visually impaired or hearing impaired or anything else. So there's an awful lot more to do in that. We kind of scratched the surface of it. Some of the solutions that we came up with that work brilliantly for hearing impaired people, and it's the right kind of metadata that we're sending with the right kind of audio and so on. It's actually quite different for someone that's visually impaired, for example. So there's engineering challenges around how we can combine these different types of metadata with different kind of scripts that might be based on the user profiles or the genre of the program and so on. And it's not just about one other aspect that we talked about, which we didn't get time to explore in that PhD, was how your set-top box or your smart TV could learn what your preferences were. So just by the way that you interact with the TV, it could gradually, over a period of time, adapt the sound scene of the media to what worked best for you. So there's a bunch of things around there, and like I say, a lot of it's been around broadcast and broadcast media and these next gen audio formats, but we've also got these new web audio capabilities that also allow personalizations of different types of media. So I'm also interested in applying these kind of things for VR, for AR, for XR. We're doing some work at the moment with volumetric video and how you can personalize audio with volumetric video. And that's partly, my main focus has been on accessibility, but I've also done some of this work in terms of not just making media more accessible, but making it more engaging, more entertaining, or better on different devices, for example, across the board. So essentially, kind of summarizing, it's studying some element of specific element of perception, people's experience of media, and then applying that knowledge to develop, to solve engineering challenges around delivery and, to some extent, automation of some of those.
Thanks very much, Ben. A question I wanted to ask you was what should, when applicants are going to ask around and get to know supervisors to choose a supervisor, and some people will know them already from teaching, but some won't know, what should people be looking for in an academic supervisor? We've talked about what a student needs to be like. What's a good supervisor need to be like?
That's a good question. I think some of it's been touched on already, and the supervisor being fully bought into and fully engaged in it. And the best kind of PhD supervisor arrangements, it does feel like you are a research team working for the same goal rather than a, you know, I say this, you do that kind of arrangement. It's more of a kind of team exercise. So definitely someone that's going to have the time for you and that's fully committed to it and motivated to it, but also someone that you can work with, that you can get on with fairly well, I think, because it can be a challenging relationship at the times when it's not going well, which there's inevitably times when it doesn't go so well. So if you're going to be on a research team with someone, it really wants to be someone that you can get along with, that you can work with well.
Yeah, I think that's a really good point, because you know, it is a one-to-one relationship in terms of, well, we do have 2 supervisors on projects, so I should say that projects usually have a co-supervisor who may or may not be very involved. But if we just talk about a one-to-one relationship with the supervisor, it has to work well. Otherwise, being a PhD gets a bit miserable, really, and you don't get the advice you need.
I suppose there's one other aspect, which is it's useful to have a supervisor who has a network that you can be introduced into. So, for example, it's quite hard to manage to get hold of people in BBC, BT, Sky, DTS, Fraunhofer. All these organisations are quite kind of closed systems and so on. And it's useful to have that, to be able to interact with what the industry is doing, and what, particularly if you're working in a fairly applied field like I tend to, it's very useful to be networked with those kind of people. And going beyond the PhD, if you're going to continue in a kind of research world, whether that's industry-based research or academic-based research, I would like to think that a PhD student ought to come out of a PhD with some of that network in place that they can build on as part of their career.
Yeah, the other thing you mentioned previously, you were talking about, you know, being teamwork. I think one thing to mention is how that teamwork varies over the PhD. So at the start of the PhD, the supervisor will be a bit more directive to get things up and going quickly. But then as the PhD progresses, by the end of it, the students should be directing the supervisor in a sense, almost, shouldn't they?
Yeah, very much so.
So that evolves over time. As I said right at the early stage, when you get to the actual sort of viva, when you're being examined, you should know more about what you've done than your supervisor.
Than anyone else, yeah.
Than anyone else, if you've done it right. Thanks very much, Ben, for that. Much appreciated. I'll just move on. Last of the staff who are actually here is Antonio. So Antonio, good, he has appeared. I just had this sort of worrying Teams moment when I didn't see his face. No, anyway, so Antonio, if you'd like to just introduce yourself and tell us a bit about the sort of great research you do.
Yes, absolutely. So, hi everyone. My name is Antonio Torillo Martinez, lecturer here at Salford. My main interest is environmental acoustics, although I've been focusing quite a lot on transportation noise and specifically on aircraft noise. I do quite a lot of things at the moment, I guess. On the top left corner, you have a picture of measurements we are doing in the anechoic chamber, and one of our research recently published, and it was from cover in a journal, international journal. So this is on perception-driven engineering, applying these methods, this approach for urban air mobility, or sorry, novel air vehicles, what you can consider a drone or even flying taxis, things like that. So we do a little bit of everything there. We do a little bit of our acoustics in order to understand the sources. We do some testing as well. Then we investigate a human response to those sounds. So the idea is to integrate human response or noise perception into the efficient design and optimization of operations of these novel vehicles with the final objective of minimize community noise impact. So the other project I'm involved at the moment is in what we call e-mobility. I think it was mentioned before by Trevor. In this case, it's on the right top corner. You have a picture in the our research was recently featured in the Guardian, and this is on scooters. So we are working with a scooter manufacturer and an advisory board, including blind associations across Europe, including RNIB here in the UK, in order to design a system and optimize a sound to be added in electric scooters to ensure pedestrian safety. It's quite a challenging process because we need to account for all the constraints of developing a hardware and software system in a really small vehicle, and also to optimize the sound with a balance between noticeability and annoyance, which is, as I said, quite challenging. But we have a postdoc working on that, and we are getting quite a lot of attention for that research. So we are hoping to expand that soon. And the other project I'm involved is with my colleague Bill Davies here. You can see this on the left bottom side of the slide, the noise app. So this is a KTP, a knowledge transfer partnership, which is quite common in our group to have those. So we are working with a company, and they have been developing this noise app, a smartphone app for participatory sensing, I would say, or to report noise complaints because of noise exposure. Bill and I, we are working with this company in order to improve the capabilities of that smartphone and helping them to get to this state of intelligence allometer, where you are able to classify sounds, to measure sounds according to increasing the accuracy of the smartphone, and also predict annoyance using that app. So as I said before, quite a variety of fields. If you are interested in any of those, environmental acoustics or aircraft noise, drone noise, e-mobility noise, even psychoacoustics, just get in touch with me. I'm happy to discuss opportunities.
Thank you very much, Antonio. And Antonio definitely lies in that bracket that Bill mentioned earlier on of new and enthusiastic member of staff rather than an old lackey like me. Anyway, sorry, I was just joking. But yeah, you seem to have a very broad range of topics there going on. I know they're all knitted together by noise. So what's the sort of background you want from your people applying to do a PhD? Because it seems to me it could be quite diverse.
It depends on, there are key areas we are interested in. For example, you focus on e-mobility or you focus on drones. You can have someone which is quite interested in the modeling part of the problem, and we will require someone with a good knowledge of acoustics, signal processing, etc. It could be someone more interested on measurements. It could be someone more interested in the actual perception, and in that case, it will be required some background on understanding of psychoacoustics. Again, it depends. The good thing, and I think it implies, it's been implied in this session, is that we are a highly collaborative group. So it's quite likely that we will have, two supervisors complementing each other with different expertise. So I think that's a strong point. So again, it depends on the particular project the students are interested in.
Yeah, and I suppose it can be blended depending on or changed according to the interests of that student and also their expertise.
Yeah, absolutely.
So thank you very much, Antonio. I just wanted to mention, and I'm sorry I clicked through earlier on, forgot I was presenting. There are staff who aren't here, and I think there's one particular area I just wanted to mention, which is vibroacoustics. So we have some great work in structure-borne sound and vibroacoustics, whether that's applied to products. We've done work for people like Dyson or aircraft, done work for people like Boeing, particularly in sort of two kind of areas. One is the block force method, which is about how you characterize systems, so metrology kind of process, but also developing what's called virtual acoustic prototypes. So how can you construct on a computer a model of a complicated machine that allows you then to sort of kind of do design work on the computer. So there's two members of staff who do a lot of work in this area. One's Josh Meggett, who's the slide I've put up here. The other one's Andy Elliott. And if you're interested in either of those, I'll get into contact with them. They do some brilliant research, but neither of them could be here today. So I just thought I'd mention that as an area we've kind of not really touched on at all.